This is a very brief introduction to 10A through to 10D, remembering that on the website, under the Topics Calculus Chapter 10 page, there are a couple of videos down here which are of longer depth. So this one goes for 20 odd minutes and it's 10A, B and C. And this one is 10D and it goes for about 20 minutes. They were filmed last year during lockdown. So a very brief overview of what today's work is about. It comes from here. Okay, so tangents and normals, we looked at way back in chapter 1. You also saw them last year. You need to use straight line rules like y equals mx plus c, or the variation of the same form, or the variation of the same form. Keeping in mind that if this is my f of x, a tangent attached at a point will share the same gradient as that point. So at the point of attachment, if that is at x equals a, then f dash of a will equal the gradient of the tangent. And then the point a, f of a, is also on the line. So we'll use our straight line maths. If we know where the tangent's attached, I can use my calculator, and my calculator can be used using the graphing component, but the equation will be given to you in decimal form, or interactive calculation line, tan line, and the equation will be given to you in exact form. There are two special cases that we need to consider. The cusp. The cusp is where the join of this hybrid function is. And what's actually happening is I have this like a square root graph, and at the origin, at the point 0, 0, it actually has a vertical gradient. And the other curve that comes in on the other side, at the point 0, 0, is joined at 0, 0, and it also has a gradient which is vertical. So at the cusp, the tangent exists, it's a vertical tangent, and it's got the equation x equals 0. So that's the first special case, the cusp. You can see this example worked for you. I'll let you have a look at that yourself. The second special case is where you don't know where the tangent's touching. For example, you might have a curve and they're telling you, put a tangent when the gradient equals 3. So you need to find out where on the curve the gradient is 3, and that's where the tangent's going to touch. Or they'll tell you that the tangent also passes through the origin, or the tangent also passes through this point here. And there's nice rules that can be used. So that's what we do if it goes through the origin, and that's what we do if it goes to another point. And can I remind you that on the website, I have 3 videos down here, tangents that go through the origin 1, tangents that go through the origin 2, and tangents that go through another point that you might like to look at. Okay, so that's 10A. 10B is about rates of change. We've already found the average rate of change. That's a rule that just looks like the gradient rule. And the instantaneous rate of change we find by the derivative. In our rates of change sections, it could be motion. So velocity is the rate at which distance changes over time. So think about dx as being the change in x, or the change in distance, and dt as about being the change in time, and that dx dt is the same as the change in x over the change in time. That is, you travel 60 kilometres in 2 hours, therefore the rate is going to be 30 kilometres per hour. Acceleration is the change of rate of velocity. I'll let you look at the video or have a little look at the example on the power slides for those answers. 10C is stationary points, and 10D are types of stationary points. To work out the type of stationary point, whether it's a local maximum, local minimum, or stationary point of inflection, we must see a sign diagram. We must see a sign diagram. So what do I mean by a sign diagram? This can be an example of a sign diagram. Here is an example of a sign diagram. As long as the examiner can see that you are considering values of x either side of where you know that it is 0, so look at a value to the left of -3, to the right of +1, and dead middle, then you can then determine what type of stationary point it is. Here you can see in the worked examples a range of sign diagrams. They're all slightly different, but they're all showing the same things. And the types of stationary points that we can have are local maximums, local minimums, or stationary points of inflection. And that will occur when the gradient is equal to 0. And in here you will find some examples like these, and you might like to look at the videos to get an understanding of what I've done in each of those to come up with these work solutions.